The chair of this week's summit is Guru Parulkar, but he is not the only guru in the room. Another one is our next speaker, DavidMeyer. David is at Cisco. He spent a lot of time at Cisco, but not in one continuous stretch. He also spent some time at Sprint, so he's got some real operational expertise. But throughout his career, he's really been a leading voice in how do we make sense of all this. He's been on the Internet Architecture Board and in the IETF. He is currently on the President's National Security Telecoms Advisory Committee for Next Generation Network Task Force. And he has perhaps a deeper understanding of what this all means and how you make it happen than most anybody else. His perspective is long-standing and broad, and it is also very deep. So pleased to welcome DavidMeyer.
Thanks, Dan. See, now all I have to do is figure out how to work this. Hey, I'm standing between you guys and food and drink. So, let's see. So when Dan asked me to talk about this, I spent a lot of time thinking about it because it's kind of an interesting question about what is the role of OpenFlow in enterprise and how does it compare to, say, for example, data center and things like that. So I spent a lot of time thinking about this. And I came up with this talk, which is sort of my ideas and thinking about this. And I think all of these ideas that I'm going to talk about at the end of the day here, we've heard about a lot of these today, but maybe if we factor them just a little bit. So here's what I think I'll talk about here. A bit about what the problem space is for enterprise. A few use cases, and I want to reflect a little bit on the promise of what OpenFlow SDN is really all about, and through a use case, and then I'll just close it up with a few challenges and what I think are open questions. So what's the problem here? So as far as I can tell, and I've heard this from everyone I talk to, basically enterprise architects and networks and network engineers are being presented with the challenge that they need to basically provide state-of-the-art network infrastructure and services while at the same time making it cheaper. Minimizing the TCO. That's a little bit of a tough job. And the thesis here is that it's the lack of ability to innovate at the network, in the network, and that results in the inability to keep pace with user requirements and to keep the TCO under control. And it turns out this is a surprisingly general problem, or maybe it's not so surprising to some of you. But what I've heard from people, or what I continually hear from people, are things like, oh, well, I have a new iPhone. I have an iPhone 4S. I got one, by the way. It's a pretty cool phone. I just walked into an Apple store and got it. Or I need to have my building be green. I need green networking in my building. And you never built the network for that. And what it really means is that these people are faced with this constant stream of new requirements. I think someone just said it's just that the perimeter of this is changing it all the time. So, okay, you can state that, but what's going on? What's the problem? Well, I like Google Images, so I typed enterprise network in Google Images, and I got this. And I looked at it and I thought, yeah, okay, that is the problem, maybe. But what about it is the problem? Well, it's kind of this. It's that every device on this is different. There's firewalls, load balancers, switches, routers, and every other kind of thing. So there's no common way of thinking about the boxes in this network. They're just all individual entities. The second thing is that the people who have to build and operate this have an extremely myopic view of it. In other words, they take a box view of this rather than a network view. And the third thing is that the policy that the network's trying to implement is deeply intertwined with the configuration of the network. And the network itself is the database of record. So this is all of these things conspire to make this a pretty tough problem for folks in this business. So, this could be the problem. See, but, it continues, because at least Ethernet's still simple, right? Over time, Ethernet's getting more and more complex too, so even the simple things are getting complicated. It's simple. So what we wound up with was this. This is a sort of an example of a sort of a mobility scenario, but basically what the picture is showing you is you have many protocols, many touch points, few open interfaces, few or no or no abstractions. So you have this complexity that's growing. And so as a result, what you see is something that, you see kind of a curve for the network that looks like this. So you want the network to be robust, but it's getting more complex. So if you look at the curve, what winds up happening is you can increase the robustness of the network to a certain degree by adding more complexity. But at a certain point, that complexity starts hurting you. And that's what we're seeing today. So you have this, if you head to the long tail, what you notice out there is that you have more and more protocols, more and more kinds of configuration, and more interactions. So it's sort of this heavy-tailed curve of robustness versus complexity. So how's this all related to SDN and all of this stuff? Well, okay, so it's that there's something that's called the complexity robustness spiral going on. Now, I come from Eugene, Oregon, so I got to work in a Grateful Dead reference here. So this picture was drawn by Robert Hunter, who was the lyricist for the Grateful Dead at one point. The animal in this thing is called an Ouroboros, which means a worm eating its tail or something. But here's what winds up happening, is that let me back up just a second. In an attempt to increase the robustness of the network, move up this curve, you have to add complexity to it. That's how you get it. But at a certain point, you start getting increased sort of sensitivity to certain kinds of failures. So what you do is you add more complexity, right? So what you get is this. And I like the way Robert Hunter described it best, is that they get greater demand, so they need larger halls, more equipment, bigger organization, larger overhead, but in order to support it, they need more gigs, so now they need larger halls, and things start going back, you know. And this is what's happening in the network world right now. And there's a real nice paper by John Doyle and et al., and cited there if you want to take a look at it, where they actually describe the actual theoretical basis of why this happens. But this is all happening to us right now because all of the complexity of the network is exposed to us. We don't have any abstractions to stop it from happening. So excuse me. So what tools do we have, and what do we get from SDN OpenFlow to address all of this stuff? Well, we've seen all this today, but I'm just going to try to reframe it this way. We have the forwarding abstraction. That's OpenFlow or the flow space, or however you want to look at it. We have distributed state abstractions. This is a global network view, logical or virtual. And we have a distributed network control abstraction, NOS or whatever we want to call it, control. So this is the key though. With these abstractions, what do we get out of this? Well, we get a unified way of thinking about the boxes in the network. They're just forwarding planes now. That solves one of the problems in the first picture I showed you. We have a centralized view of the network, right? It's not a myopic box view anymore. Now it's a logical or even virtual view of the network. And then we get mechanisms for decoupling policy from configuration. Now, OpenFlow SDN doesn't do this directly, but it makes it possible. So I want to illustrate this in a use case, but right now, the use cases that I have been talking to people about are these. Dynamic access control. Nick talked about this. I want to drill down on Nick's example just a little bit after this. Someone else, I don't know, we heard so much today. Someone else mentioned that you can make the network do load balancing now. You don't need to have a separate device. You can do server load balancing. You can do interesting things like latency equalized routing. Do people know what that is? It's like you might want to slow down some packets because overall TCP throughput might be better. You can do firewalls, NATs, network virtualization, of course, and this slicing is what people like to call this. You can also do energy efficient or energy proportional networking, which addresses the whole green question. And then adaptive network monitoring. One of the problems with network monitoring that we're having is there's too much data. Well, you might be able to using OpenFlow tailor the kind of statistics that you're capturing from the network. So what is the promise of all of this? How does it all come together in the enterprise case? Well, as I said earlier, I really like this work by Nick and his folks at Georgia Tech. It's called Decouple. I really highly advise this paper. It kind of really shows you easily how you can see what the promise of all of this is. It's by Nick and his colleagues. There's the URL. And basically, the study shows how the unified network view and of devices, and the global network view allows this elegant decoupling of policy and configuration. And the context they did it in was this WAN, or wireless LAN authorization or access control thing. So what they did was, oh, I think I have a picture, so don't read this. I just yanked that out of this paper because so the things that are bolded are saying, you know, there's a billion steps, okay? Just put it that way, there's a billion steps to get this done, okay? And that's an eye chart, but, you know, there's a lot of things that have to happen to make this happen. And it's all done by configuration, and the policy is implemented through this configuration, and it's very brittle, very baroque, all like this. So what these guys did was said, well, why don't we just build a state machine that talks about what this has to do? And then I think Nick showed this, but this is the picture. So what you do is, you build a state machine so that the controller can track the state of the hosts, and then it can just program the network in such a way that, given what state the host is in, it gives it the right kind of connectivity. So it's a really kind of a nice thing. And if you have this, once you have this, what you can do is, the next thing, you can decouple policy and configuration. So what they do is they have their policy, that state machine, that lives in their OpenFlow controller, and then the OpenFlow controller instantiates the appropriate configuration in the network. It's really an elegant approach to this. There's one other thing that's in this, is that at the controller, you could build a domain-specific language, which is a language that's tailored to the environment that you're in order to represent this. So the operators of the network could describe the policy in a succinct way that's optimized kind of for their network. So what are the challenges I'm seeing? Well, one of the things that I think we all really need to think about and work on, and this is true not only in the enterprise case, but in all of the cases, is that we really need to think about what are the theoretical or scientific foundations of all this. You know, SDN is a new way of thinking about networking. We don't have the 30 years of history behind us that we do for the sort of internet space. And this includes like distributed systems theory, new kinds of network architectures, programming languages, all of that. We need to stabilize and extend the OpenFlow protocol itself. I think people have talked today about how that's an issue because people won't want to forklift things, and that work is well underway in the ONF. There's an issue of programming languages, models, systems, and all of this sort of thing. We build applications, say, for Knox, but they're not reusable because of the nature, excuse me, because of the nature of Knox. And this is part of the goal of Frenetic. Another issue is, you know, generic ways, I think Jen talked about this, generic ways to handle streams like with functional reactive programming like Nettle. That's a very interesting thing. I really highly advise that. And then there's this issue of tool chains. If we're going to have software-defined networking and we're going to write code, we need tool chains. And what else? Hybrid model. We just talked about this a little bit. Hybrid model's a little bit thorny. If folks want to talk about that, look me up after this. Let's see. Scalability. One of the things that I wanted to ask, that I was the guy with the Northeastern shirt who didn't get to ask the question. My daughter goes to Northeastern. Is that there are scalability concerns. Like someone mentioned flows, somebody was mentioning how many flow setups per second you can do and things like that. There's proactive versus reactive flow instantiation. There's transactional throughput. These are all things we have to learn. And then on top of all of this, we need to build the operational tools and practices that allow us to operate these new kind of networks. And these are kind of generic challenges, but they are also acute in the enterprise. That's all I have. The other guru.
Dave, can I nominate you for the speaker of the day?
Yeah, go for it.
When I first asked you to come and speak, you said you don't know much about enterprise networking, and I thought you did a wonderful job, and I want to nominate you as the speaker of the day, especially coming from Cisco.
We'll take questions.
No questions.
Don't want to be standing between folks and food.
This is a rare chance to ask questions of somebody who knows stuff nobody else knows.
This might be an unfair question, but the elephant in the room is Cisco, right? So,
Which room?
my question, and it might be an unfair question to you, so if you don't want to answer it, that's fine. But you know, in the earlier presentations, they were showing the mainframes got killed by microprocessors. I come from the telco world, and the class 5 switch was a monolithic, and you couldn't develop software, and at the time it kind of fell into the same trap. So how does Cisco view, what is Cisco doing to avoid being IBM and Lucid in the transition to SDN, given that you are the market for routing and switching?
Yeah, I can answer that. Well, you know, I was just thinking of, you know, I invited David Ward to give a talk at NANOG, and, you know, when he got the similar question, he goes, you know, the weather's really nice out here. But I can't use that because I just blew that. No, I mean, I think the people at Cisco are well aware of, you know, this phenomenon. This, you know, it's very obvious to everyone that something's going on here, you know, and the question is how to react to it in a way that, you know, everybody can live with. And, you know, when you have a big company like Cisco, people need to, you know, you got to socialize those kind of things. But my sense of it is, and I'm giving you my personal view now, my sense of it is that folks get this, you know, and how to react to it is what's being formulated right now. And, you know, as you guys know, I'm kind of the one who's pushing all of this stuff inside there, as, you know, to get people to, you know, kind of start thinking about it. So, yeah, people are aware. And the weather's good. Yeah.
Go ahead, Steve.
Hey, Steve.
So, how is it that we got through a full panel on enterprise and nobody said 82.1x, CapLab, LDAP, UAC? What happened?
You know, I had a bunch of stuff about wireless controllers and this kind of CapLab and things like that in this, because I think let me make sure I understand your point. Your point is that the architecture that we're discussing here is not really anything all that exotic in some domains, right? Like, for example, in wireless. I think the reason that we're talking about it now, well, at least what I talked about anyway, was kind of trying to put a bigger, you know, kind of put a bigger veneer over it. But I mean, I don't know. I think the wireless controller case seems like that one's worked out to some extent. So I don't know. I don't really know. What's the answer? Because I think
I don't know. I mean, we've talked about, you know, OSPF and BGP, and we're going to talk more about OSPF and BGP tomorrow. I promise.
Yeah.
And I feel like I have a pretty good handle on stuff like that. LDAP scares me. Right? It didn't do Max. I don't understand it.
Yeah.
Another question? Well, personally, I also appreciate the participation of Cisco in this summit and also in the Open Networking Foundation. And they're bringing good ideas and an open mind, so appreciate that. If there are no further questions, I want to thank Dave for an inspiring talk.